You know, we bring AI into our lives for one big reason, to make smarter, faster decisions. But what happens when these super smart systems pick up on our oldest, most human blind spots? That's what we're digging into today. We're going to tackle the huge challenge of AI bias, where it comes from, and more importantly, how we can actually fix it. And you might be surprised to hear just how human the solution is.
All right, let's just jump right in with the million-dollar question. Can a piece of code, an algorithm, actually be racist or sexist? I mean, it sounds kind of crazy, doesn't it? It's just math and logic. But the answer, believe it or not, is a really complicated yes. And figuring out why that is, well, that's everything when it comes to building a better, fairer future.
So, that's the big puzzle, right? How can something we build on pure logic end up spitting out biased results? Let's get into it and really unpack that, because it's pretty much the whole point of what we're talking about today. Okay, so here's the thing about AI bias. It's not about some evil coder writing malicious code. Not at all. It's much simpler and kind of scarier. An AI is just a pattern-matching machine, right? And it learns those patterns from the data we feed it. So, what happens if that data is packed with, say, decades of our own societal biases? Well, the AI learns those patterns too. It doesn't know they're bad, it just sees a pattern. It's really the classic case of garbage in, garbage out. All right, so we know there's a problem. But you can't fix what you can't measure, right? So before we even start talking about solutions, we have to figure out how we can actually see and, well, quantify fairness. This isn't just about a gut feeling of what's right. Nope, this is about hard data and some really specific metrics. So there are a few different ways to look at this, and what's so fascinating is that they don't always agree with each other. First up, you've got something called demographic parity. This is the most straightforward. It just asks, does everyone get the same outcome rate? So is the AI approving loans for men and women at, say, a 10% rate for both? Simple enough. But then there's equal opportunity. This one's a little smarter. It asks, of all the people who should have gotten a loan, did the AI correctly identify them at the same rate for all groups? It's about being equally good at finding the yeses. And finally, we have error rate balance. This one flips it and looks at the mistakes. When the AI gets it wrong, like denying a loan to someone who would have paid it back, does it make that mistake equally across all groups? The really tricky part? You literally can't have all three of these be perfect at the same time. You have to pick which kind of fairness matters most for your specific problem. It's a tough trade-off. Okay, so we've found the bias, we've measured it, so what now? Well, the good news is, people have been working on this for a while, and there's a really solid three-part game plan for tackling it. Let's check it out. And right away, you can see this isn't about finding one magic button to press. There's no silver bullet here. It's a full-on strategy that hits the problem from three different directions. We've got to fix the data, we've got to tweak the algorithm itself, and, this is so important, we absolutely have to keep people involved.
So step one is going back to the source. It all starts with the data. Think of it like the foundation of a house. If the foundation is crooked, the whole house is going to be crooked. So the first job is to fix that foundation. That could mean going out and collecting better, more representative data. Or maybe you use a clever trick called oversampling, where you basically tell the AI to pay extra attention to the groups that are underrepresented. And sometimes it's just plain old hard work, going back through the data and manually fixing labels that were biased to begin with.
All right, next up, we can actually get our hands dirty with the code itself. This is really cool. You can literally tell the algorithm, hey, I don't just want you to be accurate, I also need you to be fair. That's called fairness-constrained optimization. There's another wild technique called adversarial debiasing. It's basically like setting up a training exercise where one AI tries to find the biases in another AI, and in doing so, it forces the first one to get better and less biased. It's like a sparring partner for fairness. And of course, none of this works without just tons and tons of rigorous testing.
And that brings us to the last piece of the puzzle, and honestly, it might just be the most important one. People. Plain and simple. Tech alone is not going to solve this problem. You absolutely need diverse teams building these things because everyone has different blind spots. You need experts in the field, doctors, loan officers, whoever, to look at the AI's results and say, does this actually make sense in the real world? And you have to keep checking. This isn't a one-and-done fix. It's more like gardening. You have to constantly watch for weeds.
Okay, that's a lot of theory. So let's make this real. How does all this stuff actually work in practice? Well, there's no better example than AI in hiring. A situation where getting it wrong can have huge consequences for people's lives.
So here's the dilemma that pretty much every big company faces.
On one side, you have this amazing tool, an AI that can sift through thousands of resumes in minutes. The efficiency is just off the charts. But on the other side, what if you train that AI on your company's last 20 years of hiring decisions? It might just learn all the biases that were present in that data. Maybe it learns that people from certain neighborhoods aren't good hires, or that a gap in a resume, which often affects women more, is a red flag. Suddenly, you're not just automating the work, you're automating the prejudice.
So what do? Well, you don't just throw the AI away. You use that three-part fix we just talked about. First, you use those fairness metrics to actually check if the hiring model is biased. Then, you put together a team of actual people to review what the AI suggests, to be a human sanity check. And you use something called explainable AI, which is a way to make the AI show its work, to make sure it's not making decisions based on sneaky things that are just stand-ins for race or gender. All right, as we start to wrap this up, there's one last really big idea I want to leave you with. It's a simple distinction that changes how you think about this whole problem, and that's the difference between bias and unfairness. Just let that sink in for a second. Bias is unavoidable, but unfairness is preventable. See, in statistics, bias just means a tendency, a pattern. Data is full of patterns. That's just a fact of life. But unfairness, that's the real-world harmful result of that bias. And that is a choice. That is something we can decide to prevent, and we have to.
So, if you remember anything from our little chat today, let it be these 3 pillars. It's the whole playbook for responsible AI right here. First, you have to be able to detect the problem using real numbers. Then, you have to mitigate it by getting in there and fixing the data and the code. And finally, you have to keep that human oversight in place. Always. It's a cycle that never really stops.
And that really leads us to the next big question, doesn't it? Because fixing bias isn't something you do just once. These AI models are always learning, always changing. The world is always changing. So, okay, you've put the fix in place, great, but how do you make sure it stays fixed? How do you monitor it over time? That right there is the next frontier in making sure this AI-powered world we're building is actually a fair one.